Today we are going to look at multiplying rational expressions. Think back to when you first learned about fractions and adding, subtracting, multiplying, dividing them, and we're going to look at how we multiplied fractions. So let's take 12 over 5 times 10 over 3. So if you remember, when multiplying fractions, we multiply straight across. So we would have 120 over 15. And then we would think, how can we reduce this? All right? And so by first glance, we see that we can pull out a 5. So we would pull out a 5, both the top and the bottom. What's left on top is 24. We have 3 left on the bottom. We would say 5 is a common factor. And then we'd look again and we'd notice that 24 divided by 3 is in fact 8. So 8 would be our answer. Now, if you think back, you may remember a little shortcut sort of way to multiplying fractions. So before we even begin to multiply, we can look to see if we can reduce. So for this, we would look diagonally. So 5 and 10 both have 5 in common, so we can change this 5 to a 1, and that 10 to a 2, because we're taking out a 5 out of both 5 and 10. Next, we can look at our 12 and 3, and they have 3 in common. So the 3 divided by 3 would be 1, and when we pull a 3 out of 12, we would be left with 4. Now that we've reduced, we can now multiply straight across. We see that 4 times 2 is 8, 1 times 1 is 1, and that just equals 8. So if you notice, if you reduce or simplify before multiplying, it is a lot easier and it seems like there's less steps. So we're going to use these same ideas when multiplying our rational expressions. All right, let's look at an example. We have 2c squared d over 5ab times a squared b over 3cd. So first thing we're going to do is we're going to try and simplify, right? So if you think back to section 10.1, so our last section that we did, that was dealing with a lot of simplifying, right? So we're going to be doing that same thing. So if we want to simplify out 2c squared d, 2 is a prime number, so we're just left with 2. We can rewrite our c as c times c, and then our d. Then 5ab cannot be simplified anymore. And then we have a times b, and 3 times c times d. Now, if you don't want to write out the prime factorization of each of the parts, you don't have to. I kind of find it helpful so then you can see all the parts and you make sure that you do in fact pull out the greatest common factor. So now let's look, and first we will look going diagonally this way, and I see that there's a C there, and also a D that we can cross out. Next we go this way, and there's an A and a B. And I think that is everything that we can cancel. So now we multiply straight across. We get 2CA over 15. All right? So this would be our answer. Notice how simplifying first is a lot easier than multiplying across and then simplifying. All right, let's look at a little more complex example here. So by first glance, obviously these are a lot different from the previous example because we have polynomials here where, we see there's addition and subtraction in them rather than all multiplication. So we need to think, is there a greatest common factor that we can pull out, or can we factor these polynomials? So let's look at the top up here, and I see that there's a greatest common factor of y. So we're going to pull out a y, and we're left with y squared minus 4. If you think back a few sections, we notice that y squared minus 4 can be factored down even further because y squared is a perfect square, 4 is a perfect square, and we're subtracting in between them, so that would be the difference of two squares. So off to the side here, we will factor y squared minus 4. So we have a y on both sides on the left, and we have a positive 2 and a negative 2. Right? So we're going to replace our original parentheses with our new ones, y plus 2, and then y minus 2. You always want to make sure you factor down as far as you can go. So y plus 2 and y minus 2, we cannot factor those any further, so we are done. Now we look at the bottom, and we have y squared minus 4y plus 4. So we're going to factor that, put a y on both sides, and then a 2 and a 2, and we see that our end is positive, which means both signs have to be the same. The middle is negative, so both our 2's need to be negative. So we have a y minus 2 and a y minus 2. Okay, now we look at this one up here, y squared plus 3y minus 10. Once again, we're going to factor that. So y and y, and then 5 and 2. We see that our last number is negative, which means one of the numbers over here needs to be negative. Our middle number is positive, so the bigger number is positive, so 2 is going to be negative. So we have y plus 5 and y minus 2. And then y on the bottom here cannot be simplified any further, so we just leave it as y. Now let's look to see if there's anything we can cancel out. Alright, so let's go diagonally. I see a y and a y. Going in the other diagonal, we have y minus 2 and y minus 2. And then another way that you can simplify is going up and down. So we have y squared on top here and y minus 2 and y minus 2. Now, you can simplify going vertically. Okay? We can simplify going diagonally. But we can never simplify going horizontally. Alright? So this is a big no-no. We do not simplify going horizontally. Alright? So now that we have simplified, we are ready to multiply straight across. And we are left with y plus 2 and y plus 5. And you do not have to FOIL that out. This, in fact, is your answer. Alright, let's do one more example. So we have 5x plus 5y over 3x squared times x y squared over 15x plus 15y. Alright, so first thing we're going to do is we're going to look for a greatest common factor or see if we can factor our polynomial. Up on the top here, I notice that both terms have a 5 in it, so 5 is our greatest common factor, and we are left with an x plus y. On the bottom, we are left with an 3 times x times x. Multiply that by the top here, it's going to be x times y times y. And if I look at the bottom, we have a 15 in common. So I like to write the prime factorization of that just so then I can make sure I simplify as far down as I can. So 15 equals 3 times 5. And we are left with x plus y in the bottom. Now it's time to cross some things out. So I see an x plus y and an x plus y, so let's cross those out. I also see a 5 and a 5. So if we would have left this as 15, then we would have had to realize that 5 and 15 can be reduced. So that's one reason why I like to write the prime factorization. So it's right there staring at you. And then if we look the other way, we have an x and an x. So we've canceled out everything that we can, so we multiply straight across. So we're left with y squared on the top and 9x on the bottom. Alright, so this is exactly the same as the section before, using the simplifying. The only thing that's different is at the end, we multiply straight across. Alright, so let's review. Step 1. Step 1 would be we find the greatest common factor, or factor the polynomial. So the polynomial, so that's all the parts of the fraction. Step 2 is we're going to cancel out like terms. And remember, we only go cancel up and down, or horizontally, or diagonally, never horizontally. So I'll write that down for you. Up and down, or diagonally. Remember, never horizontally. Alright, so step 3 would be multiply. And remember, we do that straight across. Alright, so find the greatest common factor, or factor the polynomials, every single one. Then we cancel out our like terms, and then we multiply straight across.